Hello viewers, welcome to Chemistry की pathsala. In this video lecture we are going to discuss rearrangement of carbocation. So here it is, question number first for you. This carbon connected to 3 methyl groups and adjacent position there is carbocation formation is there. Now if I will shift this methyl group, let's say this is 1,2 methyl shifting there, right? And because of the 1,2 methyl shifting, now the new structure formation is just like this, okay, and 2CH3 group is there. Now the carbocation formation here, okay. Now why I shift this carbocation? Look at here, this is alpha, this is alpha, and this is alpha. Now this carbocation is stabilized by hyperconjugation through 8 alpha hydrogens, where in this carbocation there is no alpha hydrogens there, so there is no hyperconjugation, but here hyperconjugation is there. So this is the driving factor for 1,2 methyl shifting. Clear? Coming to the next question. Similarly, this carbon connected to 3 phenyl groups are there and carbocation formation there. If I will shift one of the phenyl groups, that is 1,2 phenyl shifting. 1,2 phenyl shifting. What you observed? You observed that the formation of new carbocation surrounded by 2 phenyl groups, and this carbon connected to phenyl groups because of 1,2 phenyl shifting. Now this carbocation is stabilized by hyperconjugation, okay, and this carbocation you don't have any hyperconjugation possibilities there, no alpha hydrogens are there, so here you will find 2 alpha hydrogen, okay. This is not the end, and also you have to remember that phenyl groups are there, so that means these 2 phenyl groups shows yes resonating structure, or it will show you the resonance phenomenon. So this carbocation stabilized by 2 factors, resonance and hyperconjugation, where this carbocation there is no such case, neither resonance nor hyperconjugation there. Clear? So this is the driving factor for the 1,2 phenyl shifting. Coming to the third question. So this is the question, okay. In this question obviously you find alpha hydrogens are there, that means this carbocation is stabilized by 2 alpha hydrogens, okay. So there is hyperconjugation there, but let's say if I will shift if I will shift methyl groups here, so what happens in this case? So there is formation of new carbocation here. So because of the 1,2 methyl shifting, what you observed? You observed that this is CH3 and there is also hydrogens present here, and there is 2 hydrogens there, and there is 3 hydrogens. So you find this carbocation stabilized by 6 alpha hydrogens. Now the hyperconjugation, you know very well, hyperconjugation directly proportional to number of alpha hydrogens. So with increasing number of alpha hydrogen, the hyperconjugation dominates, and in this case therefore because of the 1,2 methyl shifting, this carbocation is more stabilized. This is the driving factor. Clear? Now coming to the next question. In this question what you observed, that this is like this is methyl, this is methyl, and this is methyl, and this is carbocation connected with phenyl and phenyl. So you have 2 possibilities there, that means you can shift methyl group or you can shift phenyl group, okay. Suppose I will shift I will shift, suppose methyl group is there. So what happens in this case? So the structure will be like this: methyl there, and the position in this position methyl group is there, formation of new carbocation, and also pH, and pH. Now this carbocation, initially no alpha hydrogens were there, but in this case you will find out how many alpha hydrogens. You will find out 3, 6 and 1, 7 alpha hydrogens. 7 alpha hydrogens established by 7 alpha hydrogens. Okay, so because of the 7 alpha hydrogens, it is stabilized, or you will say it is stabilized by hyperconjugation. Now if I will shift methyl there, so what you will observe? So there is 3 methyl group is there, and this carbon having pH, there is formation of carbocation, and there is 2 phenyl group is there. Now the thing is that this carbocation connected to 2 phenyl groups, that means there is resonance, and also it is stabilized by 1 alpha hydrogen, that is hyperconjugation. But hyperconjugation, in case of 1 to methyl shift, hyperconjugation dominate, but the thing is that here extra one factor, that is resonance here. In case of 1 to phenyl shifting, you observe there is resonance phenomenon, and you know that resonance dominates over your hyperconjugation. Therefore 1 to methyl shift is not the case here, because you have to find out the preferred formation of carbocation, so that you will justify your answer to be more appropriate. So this is the case. So phenyl, 1 to phenyl shifting is your answer. Coming to the question of 5. Okay, in this case you observed here OMe group is there. Okay, and you know very well that you have to be very tricky in this case. Now there is hydrogen present there. Now if you shift the hydrogen, why I am shifting the hydrogen? Yes, 1 to hydrate shifting. Why I am doing like this? Because the pH is there, and formation of new carbocation is here, right? Formation of new carbocation is here. Because of this formation of this carbocation, you find the carbocation is stabilized by mesomeric effect. And you know that mesomeric effect is the dominating effect in case of stabilizing the carbocation. So this is the driving force for 1 to hydrate shifting. If you shift phenyl group, okay, if you shift phenyl group 1 to phenyl shifting, so what you observed here? We observed here pH, and formation of new carbocation here. There is pH there and OMe. Now you observe this carbocation is stabilized by the resonance and hyperconjugation by 1 alpha hydrogen. Now you know that very well that mesomeric effect dominates over resonance and dominates over hyperconjugation. So therefore this is the case of 1 to hydride shifting, not 1 to phenyl shifting. Clear? Now coming to the question number 6. Okay, in this case what you observed here, this is CH3 and this is CH and then pH and then CH2 plus, right? Okay, suppose I will do 1 to hydrate shifting. So what you observed here, because of the 1 to hydrate shifting, what you observed is CH3 and there is CH3 pH and CH2, and it converted to ultimately CH3. Now it is stabilized by, yes, hyperconjugation 6 alpha hydrogens, and also stabilized by resonance. There is 2 factors. Okay, so this is case of 1 to shifting. Okay, now if I will shift phenyl group there. So if I will shift 1 to phenyl shifting, so what you observe CS3, CH and CS2, pH is there. Okay, so what you observe there is only hyperconjugation is there. Okay, so you will find out this is stabilized by only hyperconjugation because of the 5 alpha hydrogens, only. Now if I will do 1 to methyl shifting, so what you observe there, you observe that this is CS3, this is CH and this is pH, and then this CS2 and this CS3 and this positive charge. Okay, now it is stabilized by hyperconjugation because of the 2 alpha hydrogens, and stabilized by resonance also. Okay, now resonance hyperconjugation is there, but there is 6 alpha hydrogen, and in this case this is 2 alpha hydrogens, and here number of hyperconjugative structures are more in case of 1,2 hydride shifting as compared to 1,2 methyl shifting. So therefore you will not have 1,2 phenyl shifting and 1,2 methyl shifting, you will have 1,2 hydride shifting, and 1,2 phenyl shifting is ignored because only one factor which stabilizes the carbon, that is hyperconjugation. So this is your answer. Clear? That is 1,2 hydride shifting. Coming to the question number 7. In this case, what you observe? Yes, you have to be very focused in this case. Now, hydrogen present here, and you can know very well that if you shift this hydrogen, so what you observe? You observe that formation of aromatic compound. Yes, you will form aromatic compound. So aromaticity is the driving factor for your 1,2 hydride shifting. Clear? Okay. Now question number 8. In this case, pH is there, and plus is there, and this is CS3 and this is CS3. Okay. This carbocation is stabilized by 1, 2, 3, right? Total 7 alpha hydrogen. Okay, suppose if I will do hydride shifting here, that means 1, 2 hydride shifting, so what I will observe here, I will observe that this is pH and formation of new carbocation, and there is CH3 and there is CH3. Okay, now talking about this carbocation, it is stabilized by resonance and also yes, hyperconjugation, only 1 alpha hydrogen. Okay, but if I will shift the phenyl group here, okay, if I will shift the 1,2 phenyl shifting, so what I will observe here, I will observe there pH is there, okay, H is there, and you will get pH here and CS3 here and CS3 here, formation of new carbocation here. It will be stabilized only by resonance, okay, and it will stabilize by hyperconjugation of how many hydrogens? No alpha hydrogen there, so it will not stabilized by hyperconjugation. Okay, so it was stabilized by resonance. Now in this case it is stabilized by resonance, and resonance because of 1 pH and resonance because of 2 pH groups is there. Okay, now talking about 1,2 methyl shifting, 1,2 methyl shifting. Okay, talking about 1,2 methyl shifting, can the methyl will shift? Obviously no. So 1,2 methyl shifting is not possible there. So only possibility of either hydrogen or phenyl. So the answer is 1,2 hydride shifting. Clear this point? Okay. Coming to the next question. Okay. So because this is 1,2 shifting, therefore how can the phenyl will shift? Yes, so this is the answer, 1,2 hydride shifting. Clear? Okay, coming to the next question, question number 9. In this question, what you observed here, CH3 group is there, pH group is there, and here carbocation is there. This is CH3. Okay, in this case hydrogen also there. Now you have two options, either you shift phenyl group or you shift methyl group, phenyl or methyl. Okay, now thing is that you already have an idea right now that if you shift the methyl group, okay, so there is formation of carbocation here. If you shift the phenyl group, the formation of carbocation here. So let's say you shift the methyl group, 1,2 methyl shifting. So what you observed here, you observe phenyl is there, okay, and you observe CH3 there, H there, CH3 there, and formation of new carbocation here. Okay, so in this case, what you observe there? What you observe there? Now, this carbocation is stabilized by resonance, and also there is one. Sorry, this is not the case. Actually, this is not the case. So it will be stabilized by one alpha hydrogen, that is called your hyperconjugation. Clear? So now in this case, one alpha hydrogen. So resonance is the dominating factor here. Okay. Why I'm saying this? Look at here. If you do 1,2 phenyl shifting, okay, in case of 1,2 phenyl shifting, what you observed here, CH3 there, H there, and CH3 there, H there, and your CH3 there. So what you observed here? You observed here formation of carbocation there, alpha hydrogen, and there is alpha hydrogens. So how many hyperconjugative structure you will find? You will find out 4 hyperconjugative structure because of the 4 alpha hydrogens. So here what I told previously, that resonance is the dominating factor here, but here in this case no resonance is there, only stabilized by your only stabilized by your hyperconjugation. Sorry, there is a phenyl group there, okay, still phenyl, still there is no resonance, so stabilized by only hyperconjugation, and only the dominating factor is resonance. So 1,2 phenyl shifting is not there, just only 1,2 methyl shifting. Clear? Got this point? Okay, another thing is that if you do 1,2 hydride shifting, okay, if you do 1,2 hydride shifting, so what you observed here, one more possibility is there, okay, 1,2 hydride shifting. So what you observed there? Okay, so you observed there, this is CH3 is there, pH is there, and this is CH3 there, H there, and of course one more H there because of the hydride shifting here. Yes, carbocation formation there. Now this is alpha hydrogen, and this is position of the alpha hydrogens. So how many alpha hydrogens are there? 3 to 5 alpha hydrogens are there. Now there is 5 alpha hydrogens are there, and also resonance factor is there. Now in these two cases, 1,2 methyl shifting and 1,2 hydride shifting, in this case resonance is there and hyperconjugation is there. Resonance, hyperconjugation both there, but the dominating factor resonance is there, and resonance is common type of case because of resonance of one phenyl group is there. But in this case hyperconjugation come into play. Now it is stabilized by one alpha hydrogen, whereas the hyperconjugative structure is stabilized by 5 alpha hydrogens. So therefore now your answer is not 1,2 methyl shifting, this is 1,2 hydride shifting is your answer. Okay, now coming to the question number 10. In this case, what you observed here, this is pH is there, and this is like this. Okay, so there is hydrogen present there, Now what you do, suppose you do 1,2 hydride shifting. Why I'm doing 1,2 hydride shifting here? Because I need resonance. That is in my mind. There is also hydrogen there. Okay, methyl is there also, and also phenyl is there. But my objective is to make it very short or make it very comfortable so that I will satisfy my objective. So if I will shift my hydrogen there, that is 1,2 hydride shifting, what I will observe there? I will observe that this carbocation stabilized by resonance, and there is formation of, yes, 1, 2, 3 hyperconjugation, that is 3 alpha hydrogens. And in this case, what I observed that it is stabilized by only hyperconjugation, that is 2 alpha hydrogens were there. Therefore, I prefer 1,2 hydride shifting in case of question number 10. Okay, you can do it also same case in case of phenyl shifting. 1,2 phenyl shifting, you check 1,2 phenyl shifting, and 1,2 methyl shifting also you can check there. You can check there also. So you will observe that this is the most appropriate shifting because of the more stabilized carbocation formation due to 1,2 hydride shifting. Clear this point? Now coming to the next point. Okay, in this case, now 2 phenyl groups are there. Okay, 2 phenyl groups are there and carbocation is there, and there is presence of hydrogen also there. Okay, now what you will do basically, if you shift the hydrogen, so the formation of carbocation here. Okay, and if you shift this hydrogen, there is no such case. So there is only one possibility is there, that means you will shift your phenyl group. Okay, you will shift the phenyl group so that you will find resonance. You will find resonance, because in this case you cannot do this hydrogen. This is not possible. Impossible job. Impossible of 1,2. This is not the 1,2 hydride shifting, 1,3 hydride shifting, which is illogical. This is 1,2 position, so you can do this 1,2 hydride shifting, but the carbocation formation here. But you need the carbocation should formed at such position which will be more appropriate for its stability. So this is 1,2 phenyl shifting. So what you observed here? You observed here the formation of carbocation here, and how many alpha hydrogens are there, and there is formed 3 alpha hydrogens for this carbocation. So it is stabilized by hyperconjugation because of 3 alpha hydrogens, and it is also stabilized by resonance also. In this case, it was only stabilized by hyperconjugation, this 2 alpha hydrogens. So obviously, so now the resonance will dominate over hyperconjugation. Okay, so therefore you will have 1,2 phenyl shifting in this case. Now question number 12. In this case, yes, O is there. That means you have to make such a method so that you will have formation of carbocation at this position. How you will do it? Look at here. Carbocation there, and this is pH, and this is pH is there. So basically what you will do, there is formation of carbocation at this position. How will do it? If you shift this hydrogen, that means 1,2 hydride shifting. I think you have that, I think enough idea about shifting of groups, so that you will make stability of your carbocation here. So what you observed here, the formation of carbocation at this position, so that it will be stabilized by mesomeric effect. So basically mesomeric effect is safe already. Okay, therefore we prefer mesomeric effect stabilization. So this is 1,2 hydride shifting and formation of hydrogen at this position. Okay, so this is the driving force of this 1 to 100 shifting. Okay, I think this is for today. Okay, one more question is there, sorry for that. pH is there, and this is O, CS3 is there. Okay, now you shift one phenyl group. Don't do it, because there is no rearrangement there, no rearrangement, because the thing is that the carbocation already stabilized by mesomeric effect, so therefore no need of rearrangement. Suppose if you do 1 to phenyl shifting, suppose for curiosity, if you do 1 to phenyl shifting, what you observed here? You observed here the formation of carbocation at this position, and formation of phenyl group is there, and formation of already OCS3 was there. So it will be stabilized by only resonance and hyperconjugation, 1 alpha hydrogen. The thing is that, can you justify your answer? Now mesomeric effect dominates over your resonance and your hyperconjugation. So therefore, you are moving towards stability to less stability of carbocation system. So better stay there and don't do any kind of rearrangement. So this is for today's class. Thank you very much. Thank you very much for watching Chemistry Ki Pathsala. Happy learning. Thank you very much. Happy learning.